Alright, so in this video we'll calculate the center of gravity, center of mass of this extended object. Okay, what we know about this object, it's made up of three pieces. Each of the piece is a uniform piece, and if you see the two, piece one, where is it? Oh, here it is. Piece 1 is of length L, piece 2 is of length L as well, but piece 3 is half the length, and therefore the masses are going to be m, m, and then half m. Okay, and we're going to figure out the center of gravity. Now, if you watched the previous video, then you know that if I have a uniform object of mass m, then the center of gravity for this object is right at in the middle of the object. Okay, the center of the object. So what we know that the center of gravity for the first piece is at 0, L over 2. Okay. Similarly, for the second piece, it is at L over 2, 0. And for the third piece, it's in the middle of this piece, and the coordinates for this are going to be what is it? It's going to be 3/4 of L. No, sorry. It's going to be L, 3/4 of L. Okay. Now, once we know the coordinates of the center of gravity for each of the individual pieces, okay, the rest of the problem ends up becoming really easy to solve. So let's go ahead, calculate the x and the y center of gravities. So the x center of gravity will be equal to m times 0 for the first piece, plus m times half L for the second piece, plus m over 2 times L for the third piece, and then divided by m plus m divided by 2. If we simplify this, we end up getting m times L over 2 plus m over 2 times L, which ends up becoming ml, and then we divide this by 2 plus half, which gives us 5 over 2. And so this x center of gravity is going to be equal to 2L over 5. Alright. The y center of gravity will be given by m times L over 2 for the first, plus m times L for the second, and plus m times 3L over 4. And I divided once again by m plus half m. We simplify this to the algebra here, we end up getting a half plus L, which is 3/2. 3/2 plus 3/4 is equal to 9/4. So I get 9 over 4 ml, and I divide this by 5 m over 2. And if I do this correctly, I get 18 over 20, which is equal to 9/10 ml. Okay, so this problem should basically just tell you how to go about dealing with even extended objects, as long as you know the center of gravities for each of the things. Obviously, if the objects now have continuous shapes, like for instance, if I give you a triangular wedge of this sort, then the technique that we just did may not be useful. Here, calculus actually ends up really helping a lot. Okay, we're not going to worry about it. So these are the two center of gravities in the so now we know these things, and the videos that are to follow, we will try to figure out we'll find a connection between torque and angular acceleration and all that.